Good morning, year 10. We're live. Right, guys, I've got 3 people waiting. If you could do me a favor and just lob on the chat, just say hello, and that way it'll pop up with your name. And I know I've already done the register anyway. I just want to show you guys how I do this. And all I'm doing in reality is just getting you to drop a message in the chat. So say hi. And this is actually how I do the register, you see. So when you guys log in for the first one, just quickly post a message, and then I'll be able to. Hey Ethan, thanks for the message. It's a winner. Whoop whoop. Yay. Right. I am very aware that Miss Allday has sent you your homeworks. I will actually incorporate that homework into our lessons when it appears. But what I will do at the end of each lesson, I'm gonna post onto the classroom. I'll post onto the classroom. Look at this. Kate F. Who's Kate? Oh, Kat. That's gonna be Kat, isn't it? Is that Kat? Yes, it is. Oh, Kat, do you ever get called Kate? Is that why you've got that? Can I just call you Kate? Yay, I like it. Cool, I'll call you Kate. Right, so guys, this is my normal routine now. So we're on to a good start here now. So what I'll now do is I'll now share my screen with you guys. Share my screen. That drops me to here. And then I'll get rid of my face. Don't need my face. Hide. And then we'll go to here. Right, so you guys, I'm going to create a brand new section for you guys. I'm going to go down to 10A. I'm going to add a section. And I'm going to put you guys in. Put you guys as year 10. Year 10. And then I will put brackets. I'll put brackets. I'll put dual, or I'll put double science, because I think that's what you guys know it as. Yeah, double award winner. Cool. So obviously you guys, some of you guys know me and some of you guys don't. I have a very, very regular routine when it comes to a lesson. So the first thing is the topic that we're running is calculations. So you can just put your main title is calculations. And learning objectives today. The first thing I'm gonna be doing a couple of things today, but the first one is I want you guys to know the calc types. I need you to know all the calc types for dual award. Yeah, for double science, for double award. And the great thing is, you see, that list is shorter than it is for the triples, which is really nice. It gives you guys it makes it a little bit more straightforward for you guys. And it means that we can go through it with a little bit more pace. The second one is I need you guys to be able to create formulae. That's the first one we're going to do. So I'll set you guys loads of questions during the lesson and then set a homework with that on it. Create formulae of compounds. And then once we've done formulae, I'm then going to be able to calculate our very first calculation today. Calculate AR. Now, technically, that's not a calculation. That there, you can make the little nota bene. That is from the periodic table. Now, is there anybody, this is where I get you guys to be able to talk to me on the chat. Is there anybody here who knows what AR stands for? From periodic, you can just post on the chat now. What does AR stand for? From periodic table. Calculate AR and MR. I wonder if anybody knows what MR. If you don't, that's fine. And it'd be actually just as much feedback if you say, no, you don't know what they stand for. Yeah. And this is sum of atoms. You'll understand this. As I said, I'm going to do this all in the lessons. Argon. That's really interesting, Ethan. So just to explain the difference, atomic mass, almost. Oleg, well done. Just put the word atomic in there and I'm happy. So I think the first thing that we can do is just go definitions. So we have A. Now, Ethan, you said argon. Now, the difference between argon and this is that the R is subscript. That's subscript. That isn't actually on the same line as the A is. And what this stands for, by the way, there is another version. The other version is RAM, but RAM is kind of old. They don't tend to use it anymore. They tend to just use AR because it's easier and shorter. And what this stands for, these both stand for relative atomic mass. Stands for relative atomic mass. Now, can I just warn you, there is a difference between that and the mass number. Yeah, I'm going to give you more here. So relative atomic mass is the average. Now, I don't want you to worry too much about this. The average mass of one atom of an element divided by 1/12, 1/12 the mass of a carbon-12 atom. Now, guys, I know that sounds really, really long, but I don't need you to worry about this too much. Yeah, I'll explain that. I ought to do that today, really. I'm going right back to the beginning of calculations and understanding where everything derives from. It's quite tricky, this, trying to pick you guys up in the middle. Right, can I ask a quick question? You guys should be able to recognize that definition. Do you guys recognize that? This is me trying to figure out where exactly we're up to. Do any of you guys recognize it? Just post on the chat, yes or no. It just gives me a bit of feedback in terms of how far back to go. Yes, you do. That's great. Well done, guys. Good job. Fab. Look at that. 5 responses immediately. Awesome. So now I just want to quickly mention that is different from the mass number. The mass number, I shouldn't do that. I shouldn't do NO dot. I'll do mass number is actually on the, so your periodic table at GCSE, yeah, your table at GCSE, and just to quickly, I won't bother showing you it quite yet, but each element has a box, and in that box, we've got the bottom number and the top number. Can anyone now tell me which one is which? What is the name of the top number and what is the name of the bottom number? Let's do it in pieces. What is the name of the top one, please? Now, this is at GCSE, not A level. So GCSE, what is that top number? Okay, Ethan, good effort. It's not. That's the slight difficulty that I've got to do here. That number actually isn't, it's definitely not the atomic number, and it's actually not the relative atomic mass either. It is the mass number, the atomic mass number, and that is not the same thing as the relative atomic mass number. Just to tell you, just to make this even more confusing, the mass number is the total number. I'm hoping everyone's okay with me writing the word number like this, NO dot. That literally means number. Total number of blank plus blank. Does anyone want to fill in the blanks for me? The bottom number is the atomic number. Note the word mass now vanishes. This is the atomic number, and this is total number of blank. Would anybody like to? Oh, neutrons. Well done. That's great. Oh, Ethan. No, that's not correct. Not correct. It's not the electrons. Yeah, it's just, this is protons. I'll zoom in on this. Mass number is protons plus neutrons. And the bottom number is just the protons. So one of the questions you get at GCSE, yeah, so if I now do these as questions, if we just go underneath this a little bit, and go, okay, so we can now use this to say if I have carbon 12, if I have that box, and I say number, in fact, what I'll do is I'll put this at the top, number of neutrons. And year 10, one of the things that I have to teach you is it's not just being able to come out with answers in chemistry, it's a methodology. It's the way that you go about performing calculations. I need you to show your working. We need to make sure that we get into really good habits. So the number of neutrons, question mark, is going to be 12, because that is protons and neutrons. I'm going to put a little plus on the protons to remind us of this. 12 minus 6, because that is just the protons, and I will get 6 neutrons. Everyone agree? Let's run another one. Let's do lithium 3 and 7. So, guys, on the chat, please, how many neutrons does lithium have? It's nice. The reason why it's nice to have this kind of chat is I know that there's a delay. There's a delay of 3 or 4 seconds, but it also means that I get to keep an eye on how many people are just not really there and paying attention. So even if a number's already been posted, please continue to do so. Thank you, year 10, you stars. That's amazing. 7 minus 3, we know gives 4. We've got the top number is protons and the neutrons, P plus and N's. This one is just the protons, so my neutrons is going to be 4. Not complicated. It's really nice that everyone is posting. Thank you, year 10. You're all stars. Really appreciate it. Let's do another one. Should we make it a bit more challenging? Let's go more challenging. I've got iron, element number 26 and 56. How many do I now have? How many neutrons do I have? So let's see who posts first. I like this. We can race. So I've got 11. Okay, 30 eyes on it. Who is that? Who is that? Z-Han's in there. Yo, Z, well done. Smashed it. Great job. 56 minus 26. Nice and easy. Gives us our answer of 30. I think everyone's thinking, easy on this. Great. Let's make it harder. Let's go for lead. Right, now this time, folks, right, so year 10, do all of you have a periodic table? Do you have one? That you should have one in your book, or even if it's on the internet, maybe it might be worth printing one out. It would be really, really handy, because you're going to need the periodic table so much for this topic. That's great. Glad you've got one. Right, guys. So what they will do is in your GCSE is that this is never going to be this easy. This would be a level 2 at GCSE. Yeah, what they're going to do is they're going to make this much harder. They're going to give you an element and they're going to give you its atomic number. So they're going to give you lead and they're going to tell you that lead is something like, oh, this is where I don't know. This is where I don't know my atomic numbers either. I think it's like, I don't know, like, I think it weighs 207. Is it 102? Eek, not too sure. I'll have to quickly check. Lead 82. There we go. They'll just give you this and ask you for the neutron number. They will say how many neutrons. Now, what I'm hoping you guys will all realize what they're doing here. What they're doing is making you hunt for the element on your table. Yeah, they're testing to see whether or not, well done, Ethan, great job. So he's found it, it's gone to the table, he's found the element there, and that's actually part of the game. They're like, how long are the kids going to take to find their element? And then, so they get 207. So 207, let's write down here, 207, I didn't scream like a girl. 207 minus 82, and I get 125. I would never do that in my head, by the way. I'm kid you not. I am getting a calculator out right now, and I'm checking it. Yeah, I just don't trust myself with it. 125. It's a winner, and that takes my level 2 to a level 4. All of a sudden, I'm now gone from a GCSE grade F to a GCSE grade C. And it's nice to see that a simple adaptation like that is really important. I'm now going to make it harder again. We're going to make another step up. So I'm now going to give you this one. Now, this question's very different. This is a nota bene, right? Now, if you guys have never had me before, you might not recognize nota bene. Note this NB. Year 10, do any of you know what it means? I would be uber impressed. Not grab impressed, but I will be uber impressed. What does nota bene stand for? NB. Nota bene. You got to say it with an Italian accent, by the way. It's really important that. Nota bene. I can't spell nota bene. Nota bene. I don't know how to spell that. Oh, I don't think I've ever. Is it nota? I don't know. I'm gonna have to look that up now. I'm not gonna be happy unless I can spell nota bene. Nota bene. Important notes. Check you guys out. Nota. Is that how you spell nota bene? No. Is that true? Is it literally as it sounds? No, I don't believe you. I don't believe you. Nota bene. I can't spell nota bene. Nota, there you go. It's nota bene. Okay, there you go. Yeah, it means important notice. Nota bene. Nota, I'm writing it down to help me remember it. Bene. Nota bene. French for notes. Oh, actually, it's not French. It's Latin. That's actually Latin. Not French, amazingly. And then I'm saying it with an Italian accent. How can it be French? Come on. Oh, it would be in French. I can't. What's a French accent sound like? I don't know. French. Oh, nota bene. No, I can't do it. No, it's terrible. I'm sorry. I'll take that back. So, nota bene, important notice. You can put this in a sparkly box in a minute. So, we've got, what about this guy? I wonder how many of you guys are going to freak out. How many neutrons does it have? Impress me, year 10. Make me see how amazing Miss Allday has taught you and how good you guys are. How many neutrons does chlorine have? Impress me, year 10s. Come on. Come on. I'm doing like a boxing thing. Ethan, no. Z, no. Adri, no. Oleg, no. Fatima, no. Natanya, no. No. Okay. Right, guys. Do you think it is possible to have half a neutron? Ah, Kate's done something clever. Right, guys. The reason why this is really important for me to mention is because number one, you can make the little note. So number one, you cannot calculate neutrons, neutron number. I shouldn't do it. It's really bad habit. I shouldn't do it. I do it because it's shorter and it's just easier. You cannot calculate neutron number for chlorine 35.5. You can't do that. You can't have half a neutron. So there must be an explanation for this now, year 10. The reason is there are two versions. Can anyone remember what it's called if you've got two versions of an atom? One word beginning with I. You should have done this in atomic structure, and chlorine should have been pointed out very specifically. Isotopes, well done. Year 10, I'm really impressed. Thank you, you stars. I have two isotopes. The word, but just so you know, by the way, the word iso comes from the Greek. The word iso in Greek means same. The word tope in Greek means identity. Isn't that cool? I'm such a nerd. Identity. The word isotope literally translates in Greek to same identity. I think that's really cool. So what does it mean by the same identity? It means because there is actually chlorine 35 and chlorine 37. There is two versions of chlorine. Can anyone now explain to me the 35.5, please? Impress me. Question. Make it a bit bigger. Question. Why 35.5? I'm just trying to keep it short. It's the average. Great job. Thank you. Superb. It's an average. The answer. Great job, guys. I'm really impressed. Chimon, great job. So we've got the answer is 35.5 is the average mass. Guys, taking into account the isotopes and divided by 1/12 of carbon-12. So you realize that the average is actually the relative atomic mass. That's where the word average comes from in my relative bit at the beginning. Yeah, it is the average. Just to show you the maths, I have 35.5. I've got 35 isotope, that's chlorine 35. Just to show you this in more detail, chlorine 35, and that occurs that the ratio of these atoms is 3:1. So there are 3 of these. The amount of this one is 3. This is the isotope amount. The other isotope is chlorine 37, and that appears 1 in 4. So if you do 35 times by 3, or I'll show you the maths, I'll actually do it properly. So we can now work out this. So we can now do 35 multiplied by 3. We're just working out the average, folks, plus 37 times 1, all divided by the total number, which is 4, and I get an average of 35.5. It's kind of nice, that. So it's really important, by the way, guys, you need to know chlorine for GCSE. That guy there, it's actually a woman, by the way. It's female. It's a non-metal. We know that the females are non-metals. I won't explain that. If you don't know, then I won't explain it. But the females are non-metal. So that you definitely need to know her. She's important because she has 2 isotopes. Just to tell you, by the way, that bromine is also the same. Bromine actually exists as 2 people. Bromine is element number 35 and has an a mass number of 80, which is really stupid because it's not correct. Bromine actually exists in 2 versions. It is actually bromine 81, and I'll make that a bit clearer. It's not very clear, that. Bromine 81 and bromine 79. Does anyone want to guess? What their ratios are, what their quantities are to get 80 as an average? Wonder how long. It's just, I'm doing atomic structure here, by the way, folks. We dropped out of calculations. 1:1. Well done, Kate. You star. Fab. It's a 1:1. Or 50-50. 50%, 50%. These are really useful things to know. Chlorine's more important for GCSE. Bromine's more of an A-level trick. But really handy to be able to do it. Okay, so now that we've kind of had a discussion about that, what we can now do is I want to have a go at doing, we need to list all of our calculations and go back to our learning objectives. Yeah, so what we need to do, guys, is I want you now to, these are your dual award, IGCSE, dual award, or double award. I know that's what you know it as. Double award. I just prefer dual. It rolls off the tongue better. Dual award calcs. I'll put I won't do it. I'll be good. Yeah. Calculation types. Calculation types. Okay. So calculation type number 1. And by the way, there is an order. The best order to do this in. I've been teaching a long time, folks. I'm old. I'm very old. And there is a correct order for this. The first thing we need to do is we need to talk about formulae. It's the first thing to do. Formulae. And yes, that is part of calculations. I know that seems odd. Some people tie it into structure and bonding. I do both. But formulae is one of them because they tend to be part and parcel of the same thing. Number 2 is AR, subscript R, and MR. Now, of course, if you want to also put underneath that RAM, relative atomic mass and relative. These are the old ways of doing it, but you do see both. So it's nice to have it. AR and MR. Right. Number 3 is percentage composition. Percentage composition. You guys should have already done that one already as well, which is good. After percentage composition comes moles. Comes moles. Oh, the mole. Oh, I didn't show you. Do you guys want to see something super cool? I'm gonna have to turn my camera on. Hang on. Oh, I've got to show you. I'm wearing a mole t-shirt. I've just suddenly realized I've just done that live on YouTube. Oh, let's move on. Oh, that's funny. Oh, I know, right? Thanks, Kay. Thanks, Ethan. Awesome, or what? By the way, it's also made up of Avogadro's number. I know, right? It's a t-shirt with the chemistry mole on it. Right, so we've done moles. What we then need to do after moles is we then do reacting mass. We could actually do empirical formulae at that point. POG. What's POG? I don't know what POG is. Do I want to do react? I'm going to do reacting mass. Do I? No, we've counted moles, so let's do empirical formula. Empirical formulae. So you guys should have done this as well. Guys, have you done? No. You guys got up to number 4, right? That's where you guys are up to right now. That's what I've been told. Yeah, empirical formulae. And then last one is water. You've got water of crystallization. It's not the last one. Water of crystallization. Water of crystallization. Number 7 is percentage yield, I believe. I'm just checking your Joule Award spec, folks. I'm just making sure that I'm not including. So I don't want to put on the list something that you guys don't do. I'm always very aware of that. It's very easy. Let's do GCSE chemistry specification. Look how many times I've searched for that. That's amazing. I'm just checking whether or not it's part of yours to do. As I said, some of them are on triple only, you see, and I'm just aware of this, and I just want to make sure that I get it right. Oh, there they are. There's calcs. There we go. Calculate percentage yield. There you go. Water of crystallization, molecular formula from explain. Yeah, that's all part and parcel of that. Yep, absolutely. Relative formula mass. Excellent. I like it. So all you have now is percentage yield. And that's all about practicals. Percentage yield. So that's how I'm going to be teaching this to you guys. You've got 7 calcs types. Triple have 9. If any of you guys, I'd love to think that some of you guys are wanting to take A-level chemistry. If any of you want to take A-level chemistry, if you look at my YouTube channel, you'll see that I've done webinars on the other ones. Just to say, if you're thinking of doing A-level chemistry, and some of you definitely should be, yeah, for sure. By the way, just to let you know, I'm a double award scientist. I did double award for GCSE, and I'm now a chemistry teacher. So just that just shows that you can do this. Just to let you know, for triple science, this is only for the people who are thinking, do you know what? I really think I might want to take A-level chemistry. This gives you an opportunity to look at my YouTube channel and look up these lessons. Yeah, you have moles in solution. Moles in solution. And you also have moles in gases. That's it. Not complicated. Just 2 extensions from if you want to do, but these are the ones I'm going to do in our lessons. Okay, so let's do some formulae, folks. We've only got 10 minutes left. I'm very aware of it, and I will end 5 minutes, so I've only got 5 minutes. I'm just going to quickly do some formulae with you guys. So what we need to do is, in formulae, it'll be really nice to see how you guys get on with this. In formulae, we need to translate. So the question is translate. And yes, it is. I am teaching you to speak a language. Yeah, translate from word to symbol. That's what you're always doing with formulae. Translating from word to symbol. So let's say, example, e.g., let's say I give you aluminium chloride. Now this is a level 4-5, folks. A love 4-5. So this is quite a low level. And the reason why is because each of these people are found on the periodic table. Now we remember that the periodic table is designed to read. This is your best friend, year 10. This is the answer to all of chemistry. And all of this column here, all of column 1, I'm going to do that again. All of column 1 form +1 ions. Yeah, I think you guys probably all recognize that. All of column 2 form +2 ions. All of column 3, we skip these guys. These are called the transition metals. And these, because they form multiple ions. Yeah, so for example, iron forms iron 2+ and iron 3+. So we skip those, but all of group 3 forms +3. Group 4 is awkward. That's +4 or -4. It can be either. You'll use that. That jumps a level when you do that. Then it flips over. This column here is all -3, -2, -1, and 0. Don't do it, because they're noble gases. So it's nice just to remind you guys of this. So this one is a low level because you're just using P table. Yeah, so let's run it. I find aluminium, and aluminium, let's run this one. Yeah, I shouldn't have done that, should I? I find aluminium, it is in group 3, so it becomes a +3 ion. So I now remember, I'm not just teaching you chemistry here, folks. I'm teaching you a methodology. Yeah, it becomes aluminium 3+. I need to now find chloride, which is actually chlorine on the table. Chlorine is here, and that's in the -1 section. Remember, +1, +2, +3, +4, -4, -3, -2, -1, nothing. So if you want to, you can just skip that one as well. +1, +2, +3, nothing. -3, -2, -1, nothing. That's the way it should be. Yeah, so this is now a -1, Cl1-. Right, now we're going to do the X factor, cross and down, which is basically, we need to balance for charge here, folks. If I put Al and Cl together like that, well, if I did that, because aluminium was +3 and chlorine was 1-, the overall charge in this would be 2+. Well, that means it's not finished. It's going to collect another chlorine. If I go to AlCl2, it's going to still have an overall charge of +1 because the aluminium was +3 and I have -1, but I've got 2 of them. So that cancels out another one. Agreed? So the next thing is, what we then get, the final answer, of course, is AlCl3, which is the correct formula. And all I'm doing is bringing down this number down to the Cl and bringing down this number down here and getting rid of the charges. Yeah, I tend to call it the X factor. I do hate it being called that, but yeah. Let's do another one. Let's do one that you guys can now have a go at. Next. Right, so question number 1 is, let's do sodium oxide. Impress me, year 10s. Have a go at being able to post that on the chat. What is the formula for sodium oxide? Sodium oxide. Let's clear all my table, because otherwise it's going to stain it. Sodium oxide. Who's going to be the first one to post? Yeah, find sodium. Right. It's a +1 ion. So I've got Na. Well done, Kate. You're a star. O is in the 2- column. Well done, Kate. You are brilliant. Thank you. Great job, Adri. Great job, Amber. Well done. Everyone's correct so far. Superb. Na+, O, 2-, cross and down, and I get Na2, O, subscript 2. Well done, Oleg. Great job. Fab. Well done. Yeah. So, by the way, still going to be a love 4. I'm suddenly realizing if I put love like that, love 4. Yeah, still lower level. So the next thing I need to do is, I've only got 1 more minute. The next thing I'm going to do is I'm now going to mention, I'm doing this quicker because you guys have already done it, complex ions. And year 10, I'm so sorry. You've got to learn these for me. And you need to learn these until they're burnt into your brain. We have a nitrate ion, which is NO3 1-. We then have the hydroxide ion, hydroxide ion, and that is OH-. And then I have the carbonate ion, which is CO3 2-. And the last one is the sulfate ion, which is SO4 2-. Now, I want you to know how I've arranged this, folks. I've done this on purpose. Anyone who's thinking of going on to, well, hang on, there are more ions you need to learn at GCSE. You also need to learn silver ion, which is not complex, but you can't get it from the table, is Ag+1. You also need lead, a lead ion. A lead ion is always +2, lead +2, and mercury as well is always +2 as well. But those are the only ones. If you're thinking of taking A-level and you want to start doing this properly, there is another complex ion called the phosphate ion, which is PO4 3-. Yeah, you can add that one if you want to do A-level. There are others. Oh, thank you, ammonium. Thank you. Yeah, wow, that one there is A-level. Well, thank you so much. I've forgotten to do the positive one. Thank you, Kate. And the only positive complex, yeah, is the ammonium ion. And that is NH4+. Right, I've got 2 more minutes of my lesson. 2 more minutes, that's it. The one last question, and then I'm going to set you a homework on the classroom, folks. And the homework is for next Wednesday. It's not going to be long. Don't worry. It's only going to be like between 5 and 10 formulae. That's it. Dead easy, nice and straightforward. Yeah, so last question. If I do sodium sulfate, and question number 4, I just want to do one with a bracket, calcium nitrate. And by the way, that last one there, is a level, that one is a level 7, the last one. Yeah, this one here is a level 5-6, but the last one's a level 7. The reason being is you can't get the complex ions from the table, you have to build it. Yeah, so we've got Na+, SO4 2-, cross and down, Na2SO4. Yeah. And the last one, calcium 2+ from the periodic table, NO3- from my head, cross and down. This one's a level 7 because a bracket now needs to appear. I have 1 calcium, but 2 nitrate ions. Guys, I'm going to end the lesson there with 2 minutes to go, and I'm so aware that you guys will have another lesson coming up. I always forget. I'm just going to go back to this. Hey, we're back. Right, Year 10, it's been so good to see you guys and to have you guys under my care for the next couple of months. I will set the homework on the classroom literally in the next 2 minutes. But I hope you guys have an amazing day, and it's so nice to see you guys, and I hope you're all well. So take care. Have a great rest of your day. I'll leave it there. I'll pick up my learning objectives next lesson, so don't worry about that. Take care, guys. I'll see you soon.